Hello, today we show you how to name hydrocarbons with UPAC, that is the name of our video. And the objective of this video is to show to others how to draw a structure of organic compounds. First, what is UPAC? UPAC is the International Union of Pure and Applied Chemistry. UPAC has a nomenclature to name the different type of hydrocarbons. Well, now what is an hydrocarbon? An hydrocarbon is a compound entirely composed by the hydrogen and carbon atoms, and are different types of hydrocarbons that are cycloalkanes, alkane bases, alkane, alkene, and aromatic, but we only show you the last part. The hydrocarbons are classified by their bonds. The alkanes have only one bond between the carbons. The alkanes have double bonds between the carbons, and the alkenes have a triple bond, and the aromatic has an alternating double bond and single bond between their circle compound structure.
About how to name a hydrocarbon. First, you need the prefix, that is, make it with a substance. Next, you need the number of carbons, and last is the type. In the number of carbons is defined by the number of carbons, that is the first met, second X, 3 prop, 4 but, 5 pent, etc. And the type is with the type of bond, that is alkane, and the suffix "ane" is a single bond, "in" double bond, and "ine" triple bond. First, we have different kinds of formulas. First, the structural formula. In the structural formula, we need to write all the atoms involved in the equation, that is carbons and hydrogens. In the condensation formula, we use a simplest way to name it, that we only name the carbon and the number of hydrogens and have bond with this. In the molecular, we only need to say what number of carbons we have and what number of hydrogens we have. And in the condensate formula, we need to specify the number of carbons, because every line means a bond. And with examples to name it will be, for example, in this case, 1, 2, 3, and 4. So it's but is the number of carbons, and it's a simple bond, so it's ane. So the name of this compound is butane. First, in the alkanes, the main characteristic is that have a single bond, like you can see between the carbons. The formula of the alkanes will be CnH2n plus 2. For example, in this we have 2 carbons, so we can say that it's 2, and H will be H2 plus 2, so it's C2H4 plus 2 and C2H6. That this will be the formula. Also in this skeletal, we can write this compound like this, because we have the first carbon and the second carbon. Okay, next we are going to see the alkanes. The formula of the alkanes is CnH2n plus 2. So we can solve the compounds. For example, this. The formula will be that we only have one carbon, so is C1H2 1 plus 2. So the formula will be CH4. If you can see, this compound combined with the formula. For example, C5H2, 5 plus 2 is equal to C5H7 plus 2, so C5H12. In this, we can only sum the carbons and the hydrogens. So will be C3, H3, 5 and 8. And it's complete with the formula. And in the last, we obtain that we have 4 carbons. That will be C4. And the formula states that is 4 plus 2. So C4 H8 plus 2, C4 H10. To name alkanes, first you need the number of carbons. In this case is 1, so it's met. And because it's an alkane and only have a single bond, is N, and this is methane. The second, you have 5, so will be pent, and it's an alkane, so it's pentane. The third, you have a 3 carbons, so will be prop, and it's again a single bond, so it's propane. And the last, you have 4, so will be but, and it's an alkane, so it's butane. Alkanes. The alkanes have the main characteristic that have double bond, so we need to take out a hydrogen, and the formula of the hydrogens will be CnH2n. In the condensate formula we have double bond, if you can see, and the molecular is complying with the formula. And in the skeletal we have also that we need to write the double bond to explain that it's an alkane. The formula of the alkenes will be CnH2n. So we know that we have 1, 2, 3, 4 and 5 carbons, so will be C5H25, and this will be C5H10. And hexane. In hexane we have 6 carbons, so will be C6H26, and that will be C6H12. In this we know that we have 1, 2, 3, 4, 5, 6 carbons, and this will be 7, so we have C7H2 times 7, so will be C7H4. Alkenes. To name alkenes will be more complicated than to name alkanes. First you need to identify the main chain, that will be this. Next you need to identify the number of carbons in this chain, that will be 1, 2, 3 and 4. So this will be butene. Also we have another carbon, but it's another chain, so will be in the first carbon, so will be 1 methyl butene. The second, propene. Prop means three, and ne means a double bond. So this will be more or less like a C of 3 carbons and a double bond. So this will be 2, and it will be H2, H, and H3. So we have 1, 2, 3, and 4 bonds, 1, 2, 3, and 4 bonds, 1 and 3, 4 bonds. And the last, every line means a bond, so this will be 1, 2, 3, 4, 5, and 6 bonds. And this means a double bond, so this will be a hexene. But we have a 1 and 2 chains, so will be in the second and the third, so will be 2 and 2 dimethyl hexane. Alkyne. The main characteristic of the alkyne ions means a triple bond. So you can see that in the structural formula you will have a triple bond, and in the condensed formula will be combine the formulas, like the molecular formula also. And in the skeletal formula you will be 1, 2, and 3 lines. That means the triple bond and the carbons. Alkynes. First, you need to know that every bond is a carbon. So we have 4 carbons. 1, 2, 3, 4. And this is a triple bond, so will be ine, and the fourth means a butane. So it's butane. The second one. The second will have 1, 2, 3, 4, and 5. And we have a triple bond, so will be ine and 5 benzene. And the last one, we have 1, 2, 3, 4, 5, 6, and 7. This means that will be 8. And also alkynes, also we have the formula HCN H2N minus 2. So we need to apply this formula. For example, here we have 1, 2, 3, and 4. So will be 4 carbons. So will be H2 times 4 minus 2. So will be H4 H6. In the second, we have 1, 2, 3, 4, 5. So will be C5 H2 times 5 minus 2. So will be C5 H8. And in the last, we have 1, 2, 3, 4, 5, 6, 7, and 8. So will be C8 H2 8 minus 2. So will be C8 H14.
I'm going to explain the aromatics. The aromatics are hydrocarbons with alternating double and single bonds between carbon atoms forming a ring. Steps: 1. Pairing the hydrocarbon. 2. Number the atoms in the main chain. 3. Identify the number of substituent. 4. Write out the name as a single word. Example: ethanol benzene, isopropyl benzene, chlorobenzene. Structural formula: all bonds angles 120 degrees. Symmetric examples of these: propyl-benzene, phenylethene, and 1-methyl-4-propyl-benzene.